Good day, everyone, and welcome to today's DevOps.com webinar. Excited that you've joined us. We've got a great topic, tackling container iceberg, the container iceberg, how to approach security when most of your software comes from the community. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items. We are recording the webinar. All participants will receive an email with links to the webinar and to the slides, so we'll get that information to you. We also have some Amazon gift cards that we'll give away at the end, so stay tuned, hang around, find out if you won one of those cards. Our speakers are well versed in doing webinars, but they know their technology even better, so they love questions. So please pop questions into the questions tab. We'd love to have an interactive dialogue with you, both as we go and towards the end of the webinar when we have a period for Q&A. So let's move on to our topic, tackling the container iceberg, how to approach security when most of your software comes from the community. It's my pleasure to introduce two fantastic speakers. First is Jeff Martin, who's Director of Product at WhiteSource, and also Dan Garfield, who is Chief Technology Evangelist at Codefresh. So Jeff, I think you're kicking things off, so I'll hand the baton to you. Take it away.
All right. So hopefully everybody can see my screen. If not, let us know, and that you can hear me, because otherwise this is going to be a really weird demo. All right, so tackling the container iceberg. So let's kind of dive right into it here. With containers, and I'm simplifying greatly, we'll get into more depth here, but there are kind of three big phases: building it, shipping it, and running it. So not a giant conceptual jump here. However, let's kind of talk a little bit just to set the stage about what is actually in an image of in a container. And Dan, feel free to jump in here, because I know you actually know this tech much better than I do even. But there are many, many layers inside of a container that you need to be careful about, and make sure you understand what's in them, if they're vulnerable, and you need to remediate that on a layer basis based on what's in there. Basically, what do you see?
Yeah, and to go along with this, like the whole title of our presentation is like tackling this iceberg when you depend on other software. And a lot of people don't think about how they depend on open source. They're thinking, I build a simple application, I use a few libraries or whatever, but really this is my software. And really, when you think about it, like the top 10%, like the top 10% of all the code that's actually running is actually the stuff that you write. Everything else is libraries. And this is especially true with containers. And if you're using, modules, if you're using Go, if you're using Java, you're going to be using community resources, open source projects, and almost every single a vulnerability that's actually exploited to attack an organization, to attack software, comes from these open libraries, because those are the CVEs that are discovered. It's very rare. I mean, I think that I can count in instances, maybe one or two instances, and two of them are from Swordfish, the movie, is where someone actually finds a vulnerability in the actual just software that you wrote, without those just very, very rarely happen, because it requires a lot of work from an attacker's side to actually go and learn your software and figure out and poke and prod. And so it's really on these libraries that you're using that these vulnerabilities are discovered, because they're announced. We announce that a vulnerability has been found, the CVE is published, and there are two groups that care about it in a never-ending arms race. There's the security professionals who want to make sure it's patched, and there are the attackers who want to make sure they can exploit it. And so almost every single hack that's done on any larger scale organization isn't because of the top layer of your software. It's because of the 90% of software that you actually rely on underneath.
And even that, so much of container infrastructure especially is open source. So the infrastructure itself can become an attack vector. Like you said, bad actors are, they're not going to sit there unless you're, a bank and your container contains lots of money, apparently. They're not going to go and try to find instances in proprietary code a new zero-day vulnerability. That's a whole lot of effort with very low chance of paying off.
Mm-hmm.
So they are going to attack the known vulnerabilities. And if you look at just the container, even the portion of a container that's actually writable is very small. At the end of the day, you're depending on a lot of these open source pieces just to form the infrastructure alone. Never mind how much of the writable container is also going to be open source or shared code in some way. All right, so it's kind of the basics here of container security. Private versus public registry. If you are using a public registry, the images should be signed. And still a lot of people out there running containers with a root user instead of limiting that down. So Dan, help me out here. When you see this from Codefresh's perspective, how many people are on private versus public registries?
Well, almost everybody that's building, actually everyone's on both. When it comes to the applications that they deploy, those are all stored in private registries. However, very, very few people are actually building the images from scratch. They're almost always based on an existing public registry image. So like a lot of images will use Alpine as an example. That's kind of a best practice. A lot of people use Alpine. Which is great, you should. And I don't want people to listen to this talk and walk away thinking like, oh, open source software is like bad, we shouldn't use it. Good luck. You got to go build Linux yourself. Have fun with it. There's a reason that open source exists, is because it helps us get the job done. We just have to be aware of what's going on with it when we're using it. So everyone's actually using a private registry, but they're almost always also relying on a public registry to pull things like Alpine and things like that. And so even in large organizations, there are very few companies that will actually kind of bring in every image and restrict it down and then build only on those images, mostly because it's just very costly and time consuming to do that.
You do not get much out of that, honestly.
No, because even if you do that and you lock it down and you're like, oh, well, we're only going to use this version because this is the one that we rely on. Well, the community is out there fixing and updating the image and these libraries with the latest security patches, and now you've just put yourself in a position where you're for the purpose of security becoming less secure because you're not using the latest stuff.
Right, and it kind of goes to making sure you're always up to date. If you start segmenting things, you end up with silos that you end up not keeping up to date anymore. None of us are perfect about that. So talk for a minute though about signed images. To me, this is one of those things where I'm like, I don't understand why people aren't insisting that their public registries have this image signed. Do you see a lot of that? Again, just from what you see at Codefresh?
For the most part, I see that people don't really pay attention to it that much. So if images are signed, then it's happening in the background and they're not noticing it, but they're not necessarily double checking for it either. And the real danger there, I mean, if you're pulling something off of Docker Hub, the chances of the image getting spoofed are relatively low. You'd have to do some kind of man-in-the-middle attack, and that's very difficult to pull off when you're using like an SS. I mean, these are all being pulled through SSL, so it's not a slam dunk easy thing to accomplish. But by default, I mean, they should be signed.
And just one thing I've always noticed, it kind of drives me nuts, is even once you have all this and they're running the containers, they're not limiting down the permissions, which I get, right? It's like the old days where everybody just had admin access on their laptops at work. But this is one that just puzzles me, because this is a basic tenet of security, right? Least access. Anybody running a container should only give it the access it needs. Don't just hand it root. See that a little bit too much, I think. Do you agree? I mean, obviously you agree that it should be root, not root user, but
I run everything as root. I'm running as root right now. No, I totally agree, and that is something that is like a very day one kind of like, I'm just following Docker tutorials, and the easiest way to get my job done is just to just leave it as root as default. But obviously that's not a great idea, because when you think about an image, you want it to be what's that word for when something is unchanging?
Immutable.
Immutable, thank you. You want it to be immutable.
I'm a walking thesaurus, it's fine.
You want it to be immutable, right? But just because your images are immutable doesn't mean that a vulnerability exploit wouldn't modify it, right? Because if someone is able to gain access to your container and change it on the fly, you won't necessarily know about it unless you have some kind of service checking to make sure that there's not drift of any kind. So even something like root in that case would allow, even if they're not necessarily able to break out of the container and gain access to like your larger system, they will be able to modify that container, and whatever permissions it does have, they'll be able to exploit. So we're talking about remote code execution, and that's the end game, right? That means you really messed up. So running
Once
these
you let them in there, that's it.
Yeah.
All right. So okay, that was the obvious stuff. So what about the real blind spot? I just love this graphic. I feel like we got to add a Titanic here somewhere. There's so much, we talked about it a little bit already, about non-visible pieces that your software is relying on. Everybody I've seen who scans anything in a container or not in their code is always a little bit surprised to find out all of the things that are actually in there. Because the piece you use depends on so many other pieces. The dependencies are gigantic. Actually, I think it's about this ratio to 80-20. This matters a lot. And we touched on a little of this, but let's throw some data around it. We know, just it's a fact, there are more vulnerabilities now than there ever have been. It's growing pretty exponentially. We don't have the data yet for 2019, but I expect it to be very high. Certainly in 2018 to 2017, you can see this gigantic jump. I think it's like plus 35% or so. There's two reasons for this. One, there's more open source, so there's more vulnerabilities. That's kind of an easy piece. But also, we're doing a better job of reporting them. And as we, as an industry, focus on security, and that's becoming more and more of a prevalent thought in everybody's head, there's more focus being put on finding vulnerabilities and fixing them. So sort of just to establish the scale of the problem and that it is a growing problem. This problem is not going away. It's not like we're having less vulnerabilities every year. We're actually having increasing amounts.
And I think it's worth mentioning that's not necessarily a bad thing. It's actually a good thing because these vulnerabilities already exist in the software. This is actually one of the benefits of using open source, is that you have, instead of your security team, let's say that's 4 people, which may be assuming a lot. Instead of having that, you have the entire community looking for vulnerabilities and identifying them. And this is really important. Let me to back up of why this happens. These libraries are meant to be safe for everyone. They're meant to be totally secure. And these libraries are also the targets of state actors. And which means that you have entire governments putting their will and effort into finding vulnerabilities here because they want to be able to use and leverage these to attack foreign companies or foreign governments or whatever. And so when that's the level of stakes, that means people are super on top of it. And so getting these vulnerabilities out now is really valuable. There was a vulnerability just a few months ago discovered in sudo. Now we've all been using sudo for 25 years. And there's literally been a vulnerability in it for almost a decade that it's unbelievable what it is. You just have to set a negative value for the user ID and you can drop into root. That's crazy. That's crazy. And it's been sitting there for like a decade and we didn't know about it. Now someone might have known about it, but they weren't sharing. So luckily the community was able to identify it. So the fact that CVEs are going up, that is a good thing in the end for the community. And it means that your software is actually getting much, much more secure as long as you're dealing with it. And that's really kind of the thrust of the conversation today, is like actually dealing with these vulnerabilities that are spiking.
Right, and I think we established too kind of the right half of this slide, which was a few of the CEEs and when they started getting exploited. You can see as soon as it's disclosed, made public, that's when everybody attacks it. It's normal. But people aren't disclosing things until they're fixed. And so the fact that the reported vulnerabilities are rising also means there's more fixes out there, mostly in the form of updates, of course.
Yeah, and another example on this is I think the Experian hack that happened, what is it, almost a year and a half, 2 years ago?
Yeah, I was about to say it's like 2 years ago, right?
If I recall correctly, that was a vulnerability that had been known and out there for almost 18 months, which means that there was about a year and a half where their team, just because they didn't have the processes and they didn't have the discipline, they weren't getting those things patched and updated. And this is, the speed of software seems like it's a detriment. It's actually a really big positive when it comes to moving to cloud native, when you talk about using containers, when you talk about using Kubernetes, because it actually allows you to patch these things much, much faster in a much more scalable, easy way, which is kind of what we're going to get into the demo, and we'll be looking at some of the stuff deeper.
Perfect segue in the next slide. We just kind of touched on some of this. This is a problem. I think we all know this. We just covered a bunch of reasons why. There was a few more examples here that are just a little bit more container based. But some of the infrastructure you're depending on can become vulnerable, and it's extremely important to pay attention to that. Making sure, for instance, Kubernetes, you need to know when a vulnerability comes out in Kubernetes. Everybody uses it, it's there. So keeping up to date on this infrastructure level is really important as well. All right, so I like my processes. You can probably tell because I'm wearing a suit coat. DevSecOps, how do you gain this vulnerability from a discipline and process standpoint? Dan, you just mentioned Experian. The biggest problem they had was they didn't have the right processes in place. Some of that's tooling. Some of that is how you structure your team, what you focus on, how people interact. So there's this concept of DevSecOps, sort of an expansion of the DevOps model, where you're basically embedding into your root teams the actual capability, responsibility, and knowledge to be able to execute on security initiatives as well.
Hey Jeff, by the way, one of our participants jumped in and said it was Equifax and it was an Apache Struts vulnerability.
We keep talking Experian, yes.
Yeah, somebody from Experian is like, don't you dare.
Yeah,
I don't know where they're from. I won't reveal that, but just wanted to share.
I'm going to assume they're from Experian. Sorry. I'm sure you have some other security problems.
Somebody else does work for Experian.
But yeah, it was Equifax. That's correct. And yeah, that Struts vulnerability was out for it was a really long time. It was like 18 months. But thank you for correcting us, because I would keep saying that. But from a methodology standpoint, this is an important piece. You can't have visibility if people aren't tasked with the responsibility. And at the end of the day, this needs to be embedded into your processes. It's not enough just to scan it after the fact, once a quarter. It has to be embedded. So Dan, do you have anything kind of to share before we dive in a little bit more deeply on the methodology side here?
Well, yeah, and we're going to get into that actually a little bit more. So I would move to the next bit. Yeah.
Yeah. All right. So, I mean, what it boils down to is you need to have security pieces in pretty much every phase of your software development lifecycle. For containers specifically, there's clean 4 phases: initial development, the actual build phase, your CI/CD pipeline. There's a container registry that you want to make sure that you have everything scanned in there. And whoops, as I click the wrong button. Sorry about that. I don't know what I just did. There we go. Your deployment phase, right? So both deploying it in terms of continuous delivery and post-deployment monitoring, which should hopefully be tied to your container registry as well. So it's important to realize the pluses and minuses of dealing with security in each of these phases, and the fact that you really do want to do this all the way through. So what you scan when does matter. Specifically, Dan, maybe take the container registry just as an example here. With Codefresh, what do you guys see the concerns being specifically inside the registry?
Yeah, so in the registry, there's, I Actually, I maybe should have provided a slide on this. What we see as a best practice is actually using two registries. You have a developer registry, a
Mhm.
scratch registry, and it's full of whatever. You know, you don't really police what's in there. People can push vulnerable stuff in there. They can have broken stuff in there, and it's okay. It's fine because they're in process for the sake of working. That's really valuable. But then you should have a second registry that is your production registry, and everything that goes in there is golden, pristine, mwah, beautiful, ready to go images that you've scanned and checked, so that the only stuff that's in there goes in because it's perfect and ready to go. Now, there is an issue that's going to happen where vulnerabilities will be discovered at some point in the images that you already have existing. And in that case, you have to have a trigger mechanism going into your CI/CD usually, or at least an alert system that will trigger an attempted update and patch and change that would then go through the normal process to promote up. And this becomes especially sticky as you get into like, people will want to do like, oh, well, everything that I have is as code and I can always roll back and go back to previous versions, which is fine, but then you have to patch those things, because if you don't, they're never going to be exactly the same anyway, because you're going to pull down a library that's the 6-month-old version, but it's the patched version, so it has a security change in it, so it's not going to be completely reproducible anyway.
Mhm.
So it's a nice thing to try to go for, but in the end, it's kind of impossible to reach, and so I wouldn't beat yourself up that you can never get there. But in terms of the registry, a two-stage registry in this process is pretty critical because you end up having what is essentially a secure registry, and you know that you've at least checked things that have gone in there before.
Yeah, perfect. I purposely set you up on that one. By the way, I've heard you talk about the two registries before, so great. So there is this question of where inside the SDLC, but I actually think this next slide might be a kind of cleaner way of talking about it, which is in which of your SDLC processes do you really want to put this in? Integration, deployment. Dan, this is your slide, so I will let you take this away.
Yeah. So when you think about this process, I think that the component that is the most impactful to making sure that you have a secure application is actually everything that happens in the middle. You've got all your code over here, and it could be happening in GitHub and Bitbucket and GitLab, whatever. And in my experience, in most large organizations, that's not standardized. It's very rare that an organization is like, we're all on this thing, because inevitably there's like a team over here that's like rioting and like they've actually deployed their own thing for what they want to use. So that's usually not standardized. And so trying to integrate on the code layer, your version control system usually is not going to capture everything. On the opposite side, you've got all these different deployment environments. You've got stuff on-prem, you've got stuff behind the firewall, you've got stuff in different clouds, you've got your own private clouds. In fact, a lot of people don't know this, but Kubernetes is actually very popular in retail stores, where a lot of retail stores actually have Kubernetes clusters in the store that's actually providing services there. How do you integrate with all these different things? So there's not necessarily a standardized deployment framework, even though like Kubernetes does get you 90% of the way there. And so within the development lifecycle, it's the loop, right? I make a code change and there's a whole bunch of stuff that has to happen, and it's going to end up getting deployed somewhere at the end, and everything in the middle, this is CI/CD, and this is where continuous security becomes really valuable. So to give you a scenario, and this is kind of what we're going to go through in the demo, I'm happily working along on a feature. I'm making changes and I'm pushing them up, and as soon as I check those in, they go into my continuous integration and continuous security loop, and there's also a scan, and that scan can identify vulnerabilities or issues before they crop up. And even though I'm not working on something, maybe I'm not even introducing a library that has a vulnerability, but just one of the libraries that I've been using has a vulnerability, I now find this in my normal day-to-day work, and it means that everybody becomes responsible for security. So instead of just saying, hey, well, I don't have to worry about that security thing because that's like the security person's job, of course. No. Look, I'm working on my thing and I just got an alert that actually this library is out of date. I need to update it. So I'm going to go bump the version, and I'll check in my changes again and make my pull request, and now it's going to come in as secure. And now in addition to my changes, it's also going to include a security patch that's going to keep us protected and safe. And so that critical loop, that is the engine of your software development organization. And if you don't have it tuned, you're losing tons of money. And to give you an example on that, and I guess this is another thing that maybe I should have dropped a slide in for, but if you have 100 developers and your build process takes 5 minutes longer than it should, you're going to lose about $780,000 a year just on lost time. And that's not accounting for things like how you're integrating the security and getting that patched quickly, because when you have an interrupt methodology of, hey, this SVE just became known and we need to fix it, stop everything and let's go address it. That's a critical part of the security team's job, but that is also an interruptive loop that stops work so you can go work on that thing. But if you're actually checking for the vulnerabilities every time you run anyway, you'll actually pick them up and patch them just as part of the process. And so now it didn't cost you a bunch of extra time, and your developers are happier, and you still got stuff deployed quickly because it was just part of this loop. If this engine isn't tightly tuned, you end up losing, you not only making your engineers angry, but you end up losing and wasting a lot of money, losing a lot of time. And even if it's just, hey, changes take an extra week or two to get out, that's actually really, really expensive because every change you're making, it has a business value associated with it, right? So when you deploy this little change, this little tweak, it's expected to make your organization more money at the end of the day. We don't think about that as engineers a lot. But there's a reason that engineers are like the highest paid segment of these organizations. It's because they're making changes that make the organization more money. So if those changes are delayed, on average, this becomes expensive. And I talked to a friend at a large company where they were pushing a single change that was going to make the company an extra $10 million a year. One change. Now, not all changes are that valuable, but if you average it out and you say, okay, well, in this organization, if things are delayed by a week or two, what's that translate to? It's over tens of millions of dollars when you add it all up for the company. So having this loop super tight and having all of your checks running in a really intelligent, smart, and efficient way so that the developer gets the feedback immediately. It doesn't have to go to code review, right? Once it goes to code review, you've now looped into 3 other people's time. And if their job is just to say, hey, you didn't fix the thing that our automated systems already told you needed to fix, we messed up, right? So before I even opened up the pull request, I should have all this information. I should have it all addressed, and I should just push the changes.
Right. This key loop, couldn't agree more, because this key little loop is the foundation of everything else. Everything else is either an input, where it's coming from, or an output where it's going. But that core process needs to be there. Just a note you shouldn't ignore, because you can get some benefits out of screening, especially on the input side, right? Making sure people don't put in old versions of code from the beginning can help you save some time in this loop. But the foundation of the security process, especially with containers, is this core loop.
Mm-hmm.
All right. Similar to what you just talked about, the earlier you solve a problem, the less it costs. Usually you can attach money to that because developers cost money and time, but it's a fundamental true thing that the earlier you catch a problem, the easier it is to fix and the less expensive and the less people have to touch it. I'm not going to go too far into that just in the interest of time. Just sort of reiterating what you said, because there's not just a value of getting the product out the door, there's a value of how do we fix this? The earlier you get, if it goes to production and you have to fix something and go back through that whole process again, that is much, much more expensive than if you catch it early. I just liked this slide. One of my little pieces of data we got from one of our own surveys here at WhiteSource. Basically, from the people we went to, and I think there's a few thousand of them, it's spread pretty much evenly about which stage are they spending their time. So this is literally a percentage of their time. And I would argue that that core loop, as you just pointed out, which is really that build phase in this model. Not enough people are spending most of their time there. It's good that a lot of people are trying to prevent it, but I think that core loop should be the main focus. I'm guessing you agree, Dan, because we just had a
Yeah,
whole
but
other slide.
because basically what this slide versus the last slide says is that roughly 63% of people are spending a lot more to make security changes than this other 36% of people.
Yes.
And sometimes that's unavoidable. I mean, the ideal is that it's 100% in the before the post build phase, but that's an ideal to strive for. And you maybe never get to 100% just because of timing and the way things just happen. But in general, you should be pushing everything as early as possible, because when it's just one person and they're getting the information right in their hands, that's the critical component.
Right. And again, the farther you let it go, the more time that spends there, the more time you have to spend on that. All right. I purposely just kind of rushed through the last slide there because I want to get to the demo.
Right.
So let me hand this over to you, Dan.
Okay, and as we get into this, please use that question box because we love it. All right, show my screen. Okay, so you can see I've got a pipeline here. The first thing I'm actually going to do, I'm going to pull up in my Kubernetes dashboard. I'm going to be using Codefresh as our CI/CD engine here, and you can see I've got a number of different things deployed. And the first thing I actually want to do is I just want to look at this image that's currently deployed. And when we were talking about the layers on an image, see, I've got this image and I've got all this information about it, but I just want to show you the layers on this image. What you can see is all these different elements. And in this case, I made a very streamlined image. I have a multi-stage build, but really only one of these things is actually my software. It's this one right here. Everything else that's underneath this is actually the open source community software. And this one's not too crazy. If I showed you a different one, oh yeah, gosh, I've been working on this one a bunch. Let me show you a different image here. Let me show you. Oh yeah, let's get this guy. This one is not a streamlined Go image. This one's a porker. All right, so check this out. This has a ton of layers in it, right? And it's going to be only this one right here. This is, well, I guess these two. These two are basically my software. Everything else that you have sitting underneath it is from the community. And so when we talk about that iceberg, it really is large. And so if we think about it from a size perspective, I've got about 2 kilobytes of my code in something that is in total over 100 megs here. Yeah, it's an 800 meg image, and about 2 kilobytes of that is our actual application. So this is even more true when you're using Java. But that's a zinger on Java. All the people out there just got zinged. So all right, I've got this project I want to show you. This is a really simple application. I'm going to show you what it looks like. My streamlined Go app. I'm going to open up this endpoint to show you what this application is. It's just a really simple, I use it for Kubernetes demos a lot, and all it does is it displays a color, and when you click on it, it kills the container. And I did this because it's useful for showing error states. So for example, this one, if we reload this, it might have already recovered and it'll stop showing an error state on it. But let's check and see really quick. Oh yeah, it recovered too quick. Otherwise, it would have shown the drop in the state there. So that's all right. But now if we go over and look at a pipeline, I want to show you how we use WhiteSource to do this. And what we do is we have a whole library of steps that we use for security checks, and one of them is the WhiteSource step. And what this will do is this will scan anything that we tell it to scan as part of a pipeline, and then give us a report about it. So if I go over and make a change here, let's go make a change really quick. And I'm going to open up, where am I at here? Here we go. All right, so I've got, this is the entirety of my application, and some of this stuff up here is just to cause havoc on what packages and things are doing and that kind of thing. I'm just going to change the color of my application here, and we're going to go to blue. All right.
And you're just making any change so that it triggers the scan again.
That's right. That's right. So once I make this change, and this is the core loop, right? I'm making changes and I'm pushing them, and it's now going to trigger a build in Codefresh. So if I go back over here, we can see this build has now been triggered. And in this case, we don't have the step set to fail the build. I think that that's a great idea, and that's maybe something that you should consider. And I'll show you some of the kind of blocking and tackling that goes along with using WhiteSource here. You can see this is a really simple pipeline. It basically does some builds, does some scans, builds our Docker image, pushes it up, and then actually pushes and deploys this thing into a Kubernetes cluster. Underneath the scenes here, this whole thing, just as a parenthetical, this whole thing's actually running on top of Kubernetes, and it has a bunch of speed optimizations built in. So it goes incredibly fast. There's like a shared volume that's attached on an SSD. It's a distributed caching mechanism. You know, I could talk about that for like 14 hours, but time is short. So let's check out this scan here. This is going to run my WhiteSource security scan, and this will, in this case, will actually pull everything into check all my dependencies and my libraries. And in this case, I've introduced a simple problem, and it's actually one that's fairly common. So if I go over and open up my dashboard, you're going to see a whole report about what libraries I'm using. As I mentioned, this is a very simple library, really simple application, but I introduced this problem here where I'm using a GPL library. So this is a lint library that actually is GPL, what's the license on it?
GPL 3, yeah.
Yeah, now for those of you that are unaware, there's a reason that on this dashboard GPL shows up in red. It's because any use of a GPL library means that all of the software that you build has to be open sourced. So if that was your intention, then good job. But for most of us, that's not the intention. The intention is not to put an atomic license bomb inside of our software. So what I would do is I would basically go and remove the offending library. And in this case, I'm actually not really doing anything with this library. So I'm going to remove that. I remove that, and then I would remove these. In order to fix it. Now, in the case of a vulnerability such as like a version, so here I'm removing a licensing conflict. I'm also removing some potential security vulnerability issues. And what I would do is I would need to update those. So if I were to save this and push this, we should. I actually. Oh, I forgot that I need to get rid of this library too. Yeah, okay, I think I got it all right.
And just while he's fixing that, I'll mention things like the GPL license is just an example of the policies you can set up. So, you know, it's a good practice to set up, sure, licensing policies, but also policies based on the vulnerabilities. You know, maybe you want to handle high severity vulnerabilities different than the low severity. You know, if it's a non-critical small bug that doesn't have a big impact, that should be prioritized less than a gigantic critical bug in a very popular library.
Yeah, and some of these things, when you know, and I have another project just to show you as an example. I have this Hugo project, and this one has a fair number of vulnerabilities in it, but you can see they're all medium. So this is maybe not critical to cancel, you know, deploying onto. In this case, it's client-side libraries that have some vulnerabilities, and I believe in these ones they're cross-site scripting vulnerabilities. Yeah, they're all cross-site scripting vulnerabilities, which I may have already mitigated for anyway. And I believe I can because I've mitigated for those, I could actually just set these to ignore so I wouldn't get alerts on them anymore.
Yeah, maybe you can't update for some reason or something else, right? You can't mitigate it, so you just don't want to keep being bothered by this every time you're running the scan, or having it fill the build step.
Now let's go back and we'll check out our build here. I have two going. I'm going to stop this one because I forgot to actually do everything. All right, so in this case, this should clear my licensing here, as long as I did it right. So in this case, when I would come back and look at it, my project would now look clean, and once it's actually scanned, and I won't see that library anymore because it's been removed. So I've dealt with it. So by doing this scan here, by scanning during this step, I actually get that information right away. And here you can see now when this is the update to the project, is actually that there are no libraries being used. So there's actually no dashboard to even show because I removed all the libraries. So there are no more licensing or vulnerability conflicts at all. But that's actually another note just to mention, is now, in addition to vulnerabilities, which is definitely a critical part of the loop, licensing is another valuable part of the loop, where lots of times people will grab a library because it helps them solve something. They don't necessarily think through all the licensing aspects of it, but you can, as a security organization, actually set policy around this that is then consumed. Now this actual blocking and tackling, you can see the example in the color-coded repo. There's this DevSecOps branch, and with WhiteSource, you can actually set all kinds of configuration about what's going to be scanned, what kinds of issues should be a policy violation, that kind of thing. And then you can also centralize this. So in this case, I have it hosted in the repo because I'm just one person, but I could actually have this hosted in a separate repository that I pull in during my CI/CD and check against. So I could have like an organizational policy or configuration. I can have library specific policies or configuration, et cetera. And then basically we pass this in our pipeline. If we look at the YAML, this is using the WhiteSource step, and we basically just pass in the config file, which I have in the repo. I tell it what directory to scan, and then I pass in a secret for my API key that allows me to actually update my library.
Well, it's got to be secure, right?
Yeah, exactly. So if we look at my actual pipeline, you'll see that I have that key stored in an encrypted variable, so I don't have access to it. So this allows me to basically have the loop built in so that I know what's going on, and every time before I deploy, before I do my as part of my CI process, I'm actually getting the vulnerability information and then fixing it, and that way I can keep things secure and we don't leave stuff hanging out there. Now another issue is the point about vulnerabilities that are discovered in your runtime, and in that case you can actually have hooks that would trigger pipelines to automatically try to update your software with just a little bit more work, or even just an alert to your team that it needs to be tackled. Let's see, and then we didn't really get quite into image scanning. I just wanted to focus on the library scanning at this point. That may be something that we share more details on in the future, but that's the basic demo, the basic loop that we go through to get rid of our vulnerabilities, our licensing issues. In this case, I did basically just nuke everything because these were all just added as junk. But what was actually going on was, what I actually would have done in this case was I would have needed to find an alternative for this library that I was pulling in, or gotten rid of it entirely because it just doesn't meet policy. So instead of getting a quick fix in, I would basically would spend just a little bit longer to do it right the first time, and then we don't have to discover it later during an audit or during a lawsuit or during a security outage or whatever. Those are much, much worse scenarios, and we know it's much, much more expensive to fix then rather than now.
Great
Let's
demo.
see. And with that, I think we go back into my control panel here. I'll stop my share. So I think you can pull back up the presentation here.
Yes, hang on a second here.
And that's basically the end. So now is the time for
But say, I
questions.
think I just switched over just to show a thank you screen. But thank you.
But it's important. It's important, guys. Hey, good. We've got some good questions from our audience. First one, I'm not sure who wants to take this. What's involved in integrating WhiteSource into Codefresh and how you showed it today? What does it take to set that up, I guess is their question.
Oh yeah, I mean, it's wicked easy, right? I essentially showed the components. You drop in the step that we talked about, which is sitting in the library. So when you're just building a pipeline, you can literally just on the right-hand side search for WhiteSource and just drop it in. And then you just pass in the API key, which means you have to get the API key from WhiteSource. So you create a WhiteSource account, and then you can you basically drop that in and drop in the unified agent configuration, which is available in that color-coded repo at the Today Was Awesome color-coded app on GitHub. So you're welcome to take and tweak mine if you'd like, and they have great documentation on it.
Okay, great. Next question is for Dan. What do you find are the biggest issues for patch management through this process, and how do you avoid them?
Yeah, so I would say, gosh,
It's a rough one, huh?
yeah, that's a good
It's
question.
pretty open-ended. You can, but what have you seen are some of the bigger issues folks run into?
Well, the biggest issue I see is that people actually aren't doing the security checks during their CI process. And that's kind of the focus of this talk on how to fix that. But the other potential issue is that when you do introduce the security check early on, you may expose it to a developer who is working on something very unrelated and doesn't have the insight or understanding about how to fix it. And in that case, that's why in this build process, I actually didn't block the code from moving forward, because I basically just wanted the alert to happen so that the relevant people can deal with it. So the responsibility scope can be tricky, and it also gets tricky depending on what kind of architecture you're using. So if you're using like a monolithic architecture, the probability that I discover a vulnerability that I know nothing about, it goes up much, much higher. If I'm using a microservice-based architecture, the probability that I discover a vulnerability that I don't have any insight into is very low, because I'm basically scoped to a specific project, specific service, and it's something that I should be in general familiar with. So that's actually kind of on an organizational and architectural standpoint, something that's important is if you're using microservice-based architectures, which most people are, or are moving there because there's so many advantages, then the security alerts that I get are for stuff that I'm more responsible for. So that really goes to not just a technology choice, but an organizational choice around you want your developers to feel totally responsible and have the ability to take on these things. And it's not the security team's job to do all the security. It's everyone's job to take security seriously. Because if you don't, then you have a vulnerability, right? If one person doesn't think security is their job, that's the exploit vector. So it's both an organizational thing as well as a technology thing. This stuff that we're showing you is a bunch of technology that helps enable this. But if you don't culturally make a shift to say, hey, we're all responsible for fixing these things, then it's not going to work. It's just going to lead to a bunch of people saying, oh, I'm going to ignore this because it's not my job, right? So you have to have an organizational shift with this to say, hey, we're all responsible for security. And the other thing I would mention, this is a really loopy one. I actually saw this firsthand years and years ago at a company I won't mention. We had a developer open a malicious email, and their system was they were hacked, and they actually slipped malware into their code commits. And so they pushed code that had malware stuck into it because they had opened this wrong email, and these are like Outlook days, right? And so because there wasn't a security check mechanism, there was actually a malicious attack that was successful that would have been caught if we had something like the system that we showed you here today.
Crazy. One note on process there is, if you're just implementing, do not dive in and immediately start failing builds.
You
Sounds
become
crazy.
the pariah of the team very quickly.
Suddenly you're everybody's least favorite person.
Hey man, I like it. Throw them into the deep end.
I mean, why is every build breaking? Well, because we have a lot of these old things we haven't fixed yet. I mean, get a baseline first, then maybe consider flipping on, breaking builds.
Yeah, to that point, and also what you were talking about, Dan, in monolith situations, right? A lot of folks live in that environment today, maybe moving parts of their apps and into Kubernetes containers, et cetera. What is a good scanning strategy for a monolithic application, right? It's another scenario. You just don't want to throw all the scan results to everybody about everything. How do you kind of divide and conquer that kind of a situation?
Yeah, that's a good question. So with monolithic applications, you basically have to have much tighter couplings between the teams so that they're working together more closely in order to and have higher levels of communication so that you can tackle these things together. What's I think more common though is actually here's a thought. Instead of thinking about the monolithic application attack surface, underneath that is the infrastructure attack surface. And if you are using something like Kubernetes, that actually is going to make your life a lot easier, because in the case of we keep on saying Experion. It's driving me crazy now that I can't. It's like when you say the wrong name 3 times.
Thank you.
Yes.
Yeah. In that case, this was an infrastructure related one, not actually an application related vulnerability. But if they were using something like Kubernetes, infrastructure as code, containers, then all of that infrastructure would have existed as code that they could have checked and modified much more easily, rather than what realistically, and I don't have this in-depth of a knowledge of that particular attack, but realistically they probably had thousands of servers that needed to be updated with their underlying software, and they just didn't have the infrastructure management done as well. And that's one of the frustrating things about security, is that it's an attack surface problem, right? The larger the attack surface, the bigger the problem. By using some things like Kubernetes, even monolithic applications get a lot of advantages because they get that infrastructure as code, and now you have an easier way to do stuff.
One other note on the monolithic pieces, too often people think tools are just going to solve the whole problem. Especially with monolithic applications, process becomes pretty much more important than the tooling, because you can't just alert everybody, right? What you want to do matters as much as how you do it, especially if you're dealing with that monolithic application type. At the end of the day, you need to put a lot of thought into who you want to have fix what, why them, and what you're going to bother them with. It requires a lot of actual thinking, process, kind of the boring stuff that developers don't like to do, right? But it does involve a lot of that. Setting policies, for instance, helps a lot there. Only alert me on the big severity ones. Don't bother me with medium. If it's not critical, we're not going to deal with it yet. Those kinds of decisions need to be made to handle a monolithic application efficiently, without driving everybody insane and having no tool adoption because nobody likes getting bothered all the time.
You know, if I can jump in just to give a little flavor of something what you're talking about, and also Dan that you mentioned. So sometimes the idea of everybody owns something, everybody owns security, means that it kind of becomes, well, nobody's doing it, right?
Yeah.
So this has happened to be a topic that I talk on quite a bit, and that is, yes, everybody owns security, but you want to have some lead folks, right? There's going to need to be some some people who work together to decide what's our scanning strategy, how are we going to approach this, how are we going to communicate this, how are we going to resolve it when we need to pass things back and forth, all of that. So you're still going to want to have, I think, some folks in a lead role across those teams that are working together and working within teams on your whole security strategy, scanning, remediation. Do you agree, disagree? What are your thoughts?
Yeah,
I mean,
you definitely
fundamentally, you should always have leads on subject matters, right? So there should be subject matter experts in this, and you should embed them in the teams if you can. But at minimum, you do need somebody who's ultimately setting these things up, right? Often it's your DevOps guys putting it into the build steps.
Mm-hmm.
I
Yeah,
mean, Dan,
we actually didn't touch deeply on this, but this is where a security team setting policy in something like WhiteSource becomes really, really valuable, because the security team can actually set policies in WhiteSource that then becomes the information that everybody consumes. And if you basically say, okay, well, look, these high vulnerabilities, that violates our policy, especially for these applications. So as a developer, I'm working on it, and these policies are basically telling me this is the thing that we have to fix. And at that point, you can introduce some additional gates and say, look, you can CI, and we won't fail your CI ever on your development, but your CD, you're not getting anything into the CD gates that violates the policy. And so you can work over here as much as you need, but at the end of the day, when it's time to get into production, we're not pushing anything until we address it. And that's where somebody taking the lead and setting a policy becomes really valuable, because it starts to enforce the culture and best practice of 100% responsibility.
Mm-hmm. Great. Well, I'm going to do something really unfair and ask you to attempt this question in about 2 minutes. So question is, as how does this kind of a solution help with API economy or apps that are built that are API centric, internal to the application as well? How does that affect this kind of an approach?
it's an interesting question.
Unfair.
Yeah, that's okay. I'll dive in for a second though, because inherently what usually microservice or heavy API usage applications, they depend on trust to some degree, whether that's internal or external. You can only trust things you know what's there and that you know it's secure. So if you have many, many different pipelines and you're heavily distributed and your application is dependent on multiple services, despite the fact security is everybody's responsibility, the pieces fall into different buckets. And each person has to be sure that their bucket is secure so that everybody else can trust it. It actually, in my view, ups the importance of security even more, because you have to have that trust model.
Well, I actually would flip that on its head a little bit and say that your services have to be engineered in such a way that you don't trust all of the inputs that are coming in, right? Because they're external to you. And what you're saying is totally right. Like, you need to be able to trust that you can handle the inputs that are external, right? And so you, in a sense, need to trust none of them.
It's actually kind of the same thing, right? It's because you need to make sure your piece is secure by making sure it can handle all of the inputs that it gets, and no matter what you get. But at the same token, other people need to trust that you're not going to be that weak chain in the link.
Yeah, Linus said something great last week in a thread that blew up, where he said that our software should be built in such a way that bad code won't break it.
Yes.
And so, like, your service has to be built in such a way that bad, insecure external services won't break it.
Well, it sounds like we need a whole nother webinar on that topic. So I told you I was unfairly asking that question.
But
well,
secure API design is so big anyways.
It is. Well, Jeff, Dan, appreciate it very much. Thanks to our audience for those great questions. Just a reminder, we'll send out an email with links to the webinar recording and slides. And also check out devops.com for future webinars. Just a reminder, we had a Security Boulevard webinar that Jeff was on security pros and cons of open source software. So check that out. It's a really good discussion. Let's talk a little bit about our Amazon gift card winners, Pamela T, Jeff O, and William R. And we're also going to add 2 more to the list. We want to thank both Sanjay and Vincent, who helped point out our Equifax error. So we're going to also give you both of you gift cards. Thank you for helping us out.
Thank you, and I apologize again for the slander. My bad.
Hey, it's we all make mistakes. No
Financial
worries.
company that starts with an E, it's an easy mistake.
No, I think it's probably important to them, but yes.
Yes.
So join me in thanking Jeff Martin, Director of Product with WhiteSource, and Dan Garfield, Chief Technology Evangelist with Codefresh. We appreciate that all of you have spent this hour with us. We know your time is extremely valuable, and the fact that you spent it with us, we appreciate that very much. Join me. It's been my pleasure in hosting today's webinar, and I hope everyone has a great day and be careful out there.
Bye, guys. Thanks.
All right.